Hey, this is Mr. Drogemeyer. Thanks for joining me for our Algebra 1 lesson videos. Today we are in Unit 7, looking at lessons 8 and 9, graphs of linear inequalities. And so we've talked about all these different aspects of these linear inequalities. Now we want to look at what they look like when we represent them on a graph. And so the thing that's different with an inequality compared to an equation is that you have many possible solutions um, for that inequality. And so we represent that with a shaded area. And so I'm going to zoom this in just a little bit better so we can see those graphs a little bit more. So with this first example that I have, we want to write the inequality that's represented by this graph. And so you'll notice that there is a dashed or a dotted line there before the shaded area. And so that's one thing that we want to pay attention to when we're graphing these linear inequalities. If it is a strict inequality, which if you remember, strict we said is either less than or greater than. So those strict inequalities, less than or greater than, we're going to use that dashed line to represent where that shading begins. If it is a non-strict inequality, so we have less than or equal to or greater than or equal to, in that case we will have a solid line, and that's just showing that on that line, those values that are on that line are also solutions, valid solutions for that particular inequality. So if we look at this first one, we want to write the inequality that represents this graph. Well, if you notice our line here, that is a vertical line. And when we talked about equations for vertical lines, we said we're going to look at what is that value for x that is consistent on that line. And you'll see that this one is at x equals 1. And so our equation that we would be using would be x equals 1. But since this is an inequality, we need to use an inequality symbol. It's a dashed line, so it's either going to be less than or greater than. And so these values that are shaded are values that are greater than x equals 1. And so our inequality here would be x is greater than 1. If I choose any x value that's greater than 1, it's going to show up in that shaded area. All right, let's take a look at the next one. So again, we have a graph, and we want to write the inequality. Again, we have a dashed line, and so that tells us it's a strict inequality. So that means we're using either less than or greater than for our symbol. We want to think about what would the equation of this line be. Well, when we're talking about finding an equation, we can use slope-intercept form. The y-intercept is right here at -2. So our y-intercept is -2. Then we want to know what's the slope. Well, if we just look at our intercepts, to go from here to there, I'm going up 2 and to the right 4. So up 2, that's my numerator of my slope. My denominator to the right 4, that would be 4. So 2/4 simplifies to 1/2. So 1/2 is our slope. -2 is our y-intercept. So if I was writing the equation, it would be y equals 1/2 x minus 2. But we're not doing an equation here, we're doing an inequality. So instead of equals there, we need to use either less than or greater than. And to determine which one we want to use, we're going to look at that line. And if it's greater than, then we're going to shade above that line. If it's less than, we would shade below the line. Well, this is shaded above the line, so that tells me that it's going to be greater than. So y is greater than 1/2 x minus 2. You can also check these if you pick a point that is in that shaded area. So if I just choose the origin point, 0, 0, if I plug in that x and y value, so if I plug in 0 for y and plug in 0 for x. So instead of x there, I'm going to make that 0 minus 2. Well, 1/2 times 0 is just 0. So I get 0 is greater than negative 2. And that is true. 0 is greater than negative 2. So it does look like we've got that represented correctly in our inequality. All right, our next one here asks us to graph an inequality. So we have 3 times x minus 2 is greater than y plus 4. And so if I was going to graph this, I would first want to simplify it and get it into that slope-intercept form that we've been looking at, where we have the y value by itself. So I'm going to go ahead and distribute that 3 to each term. So 3 times x is 3x. 3 times negative 2 is negative 6, greater than y plus 4. And I want to isolate that y, so I'm going to subtract 4 from each side. And when I do that, I get y here. And then this would be 3x. Negative 6 minus 4 would be minus 10. And so I'm going to flip this so that it's going like my normal slope-intercept form. If I switch everything around, I also have to switch the direction of that symbol. So y is less than 3x minus 10 is what I'm coming up with for that inequality. And so if I want to graph this, I'm going to plot that y-intercept of negative 10, my slope of 3, my line is going to be a dashed line, and then my shading is going to be below that line because it is less than. And so I did go ahead and put this into Desmos so we could take a look at that. Let me pull that up here. So y is less than 3x minus 10. Let me zoom out a little bit so we can see there's our y-intercept of 10. A slope of positive 3 means I go up 3 into the right 1 for each, or to get to each point. And then, like I said, the shading is going to be below the line because it's less than. I also went ahead and plugged in the original equation that they gave, or inequality that they gave us, just to show you that it does match up to what we were seeing there. So you can plug that into Desmos if you want to check your work, just so you can see that. All right, and then we've got one more example, I believe, here. Let me pull that back up. So again, we're given a graph. We want to write the inequality for that graph. Notice this time we have a solid line that's drawn. And so that tells us that this is a non-strict, so it's either less than or equal to or greater than or equal to. Our y-intercept here is at negative 3. And looking at our slope, we're going up 1 and to the right 1 each time to get to the next point. So 1 over 1 is just a slope of 1. So thinking about the equation of our line would be y equals 1x, or x, minus 3. Minus 3 or negative 3 is our y-intercept. But this is an inequality, so instead of using equals, we need to either use less than or equal to or greater than or equal to. Our shading is above the line, so that tells us that it's greater than or equal to that x minus 3. And so this would be our inequality to represent that graph. All right, and that's all I've got for you guys today. Appreciate you taking the time to watch. As always, if you do have questions, please let us know. Thanks. Have a great day.